For decades, it was just another frozen giant in the darkness, a planet we thought we understood, one that hadn't changed in millions of years. It sat on the edge of our solar system, distant and silent, with no signs of life, no activity, and certainly no reason to look again. Scientists had labeled it a relic, cold, calm, and dead. Even the most advanced telescopes showed only stillness, until now. Because when NASA's James Webb Space Telescope aimed its powerful infrared lens toward this long-forgotten world, something unexpected happened. Movement. It wasn't a storm. It wasn't a moon. It was something happening deep within, the planet itself. Something that suggested heat, energy, and maybe even a kind of awakening. The readings didn't make sense. Temperatures shifted, clouds formed and vanished. A planet once believed to be frozen solid was suddenly alive. This wasn't just a glitch or a fluke. It was a revelation. One that might change how we view not only this distant planet, but the entire solar system. So, what exactly did Webb see? And why is it sending shockwaves through the scientific world? This is the story of the moment everything changed. The forgotten ice giant. For a long time, Neptune has been one of the most ignored planets in our solar system. It's far away, freezing cold, and wrapped in clouds that made it nearly impossible to study in detail. To most scientists, it was just a giant ball of gas and ice drifting in the darkness, with nothing going on beneath its cloudy blue shell. It was considered dead, not in the literal sense, but in the sense that nothing exciting was expected to happen there. No new storms, no active heat, and definitely no movement. That belief started decades ago. Since Neptune is so far from the sun, it gets almost no sunlight. The temperatures there can drop to 214 degrees. That's colder than any place on Earth by a huge margin. Because of this, astronomers thought it was impossible for anything to be active on Neptune. It was just too cold. Even its magnetic field is strange. Unlike Earth's field, which comes out neatly from the poles, Neptune's magnetic field is tilted. It comes almost 50% off-center, which is weird and hard to explain. Scientists couldn't really make sense of it, but they didn't dig too deeply because the planet seemed quiet. We've only sent one spacecraft to visit Neptune, NASA's Voyager 2, and that happened way back in 1989. It gave us our first real pictures of the planet. We saw giant storms, including the famous Great Dark Spot, which looked like a huge hurricane. But after Voyager left, Neptune faded into the background. There were no follow-up missions, no close-up photos, and very little attention. It became a mystery planet, one that we knew existed, but didn't expect to change. Neptune's most well-known moon, Triton, is also unusual. It moves in the opposite direction of Neptune's rotation, which is called a retrograde orbit. This kind of motion is rare and suggests that Triton might not have formed around Neptune at all. It could be a captured object, something that drifted too close and got pulled into orbit. Even so, both Neptune and Triton were labeled as cold, inactive worlds. No heat, no motion, no reason to look again. All of that changed recently when NASA's James Webb Space Telescope turned its massive eye toward Neptune. What it saw surprised everyone. For the first time in over 30 years, we weren't just looking at a cold blue ball. We were seeing signs of something happening. And that's where the mystery begins. A planet that we thought was silent is now showing signs of activity. The idea that Neptune is dead is being replaced by a much bigger question. What did we miss all these years? This is where the story truly starts. Not just with a telescope, but with a shift in how we understand the outer solar system. Neptune is no longer just a forgotten giant. It's waking up. Or maybe it was never asleep to begin with. Neptunes. Harsh legacy Neptune has always been a difficult planet to understand. First off, it's 30 times farther from the Sun than Earth is. That means it barely gets any sunlight, and its atmosphere is one of the coldest in the solar system. Scientists used to think this made it inactive. Just a cold, windy world with nothing much going on. But even in the past, there were clues that Neptune might be hiding more than we realized. The planet has extreme weather. Its winds can reach speeds of up to 2,000 kilometers an hour, faster than the speed of sound. That alone should have been a clue. No other planet has wind that fast. Jupiter comes close, but Neptune's windstorms are on another level. They circle the planet in huge bands, stirring up white clouds of frozen methane. At such low temperatures, these clouds form in the upper parts of Neptune's atmosphere, creating strange, beautiful shapes that don't last long. Beneath these clouds, Neptune has layers of gas and liquid. At the top, it's mostly hydrogen and helium. Lower down, you'll find methane, ammonia, and water. Some of these gases turn into ice under pressure, forming a strange ocean of thick, slushy material. Not solid, not liquid, but somewhere in between. And deep below, that is a rocky core surrounded by heat from Neptune's interior. Scientists, though, always assumed that this heat wasn't strong enough to cause much movement, but that idea is now being questioned. There's also the matter of Neptune's magnetic field. Unlike Earth, where the magnetic field is centered and symmetrical, Neptune's is lopsided. It doesn't line up with the planet's rotation. This makes the field wobble and twist in unpredictable ways. It's been hard to study because of how far away the planet is, but the more we learn, the stranger it gets. The fact that it's misaligned by nearly half the planet's diameter has made scientists wonder what's going on inside. Is something churning down there? Something we didn't expect? Even gravity works differently on Neptune. If you weighed 100 kilograms on Earth, you'd weigh 113 will be there. That's not a huge difference, but it tells us that Neptune's gravity is stronger. And that strength might affect how the planet holds heat and energy. But for decades, we didn't ask these questions seriously. Neptune was cold, far away, and hard to study. It was easier to leave it alone. But now, with new images from the James Webb Space Telescope, all of that is changing. We're starting to see patterns in Neptune's clouds that don't make sense. We're spotting strange warmth near the poles. And perhaps the most surprising of all, we're seeing movement, not from storms alone, but from temperature shifts and light changes. Neptune might not be as quiet as we thought. Something beneath those clouds is happening. And if it's happening on Neptune, what does that say about the rest of the solar system? The idea that Neptune is a dead planet doesn't hold up anymore. In fact, it might be one of the most active and mysterious worlds we've ever studied. And the more we look, the more questions we're finding, not just about Neptune, but about everything we thought we knew. James Webb's unthinkable image. Everything we knew about Neptune started to shift when the James Webb Space Telescope pointed its powerful lenses at the planet. Webb isn't just another space telescope. It can see in infrared, which means it captures heat and light patterns that the human eye, and even earlier telescopes like Hubble, couldn't detect. When it looked at Neptune, scientists expected to confirm what they already believed. A cold, distant, mostly silent planet. Instead, they saw something completely unexpected. Neptune didn't just show the usual bands of icy clouds. In the infrared image, it appeared darker than ever before, especially in regions that were thought to reflect a lot of sunlight. This surprised scientists because older images had shown Neptune as bright and glowing blue. But here, the planet looked like it was cloaked in shadows, broken only by glowing rings and unusual heat spots. Then came the bigger surprise. James Webb picked up a faint glow near Neptune's south pole, a thermal hotspot. This wasn't just a bright area in the picture. It meant that something was heating up, and it was happening quickly. Data showed that the temperature at that spot had increased by nearly 20 degrees in just a few years. That might not sound like much, but for a planet like Neptune, where change is supposed to be extremely slow, it was a shock. Even more mysterious was the way the heat seemed to shift. It wasn't just sitting there. It moved slightly across the planet's surface, almost like a ripple in water. That movement, combined with other heat signals across the atmosphere, suggested that something was going on beneath the clouds. Something scientists didn't expect from a planet that had always been considered geologically quiet. And then there was Triton. In the same image, Neptune's moon Triton appeared brighter than Neptune itself. That's strange, because moons usually reflect less light than the planets they orbit. Triton was glowing in the infrared, like it had its own heat signature. This led some scientists to wonder if Triton and Neptune were part of the same event, maybe something linking their heat, motion, or magnetic fields. The Webb image flipped decades of assumptions in a single snapshot. Neptune was supposed to be a background planet, cold, calm, predictable. But now we were seeing signs of heat, motion, and something much deeper. James Webb didn't just take a picture. It opened a door to questions we didn't even know to ask. What could be causing Neptune to heat up? What force is making energy rise in a world that was thought to be frozen solid? And most importantly, what else might we find if we keep looking?